Hello, everybody. Today we're going to talk about rational and irrational numbers. And the standard that we're addressing today is A.NR.52, which deals with numerical reasoning, show and explain that the sum or the product of rational numbers is rational, and the sum of a rational and irrational number is irrational, and the product of a non-zero rational number is an irrational number is irrational. So, talking about all these rational and irrational numbers, let's talk about what those numbers specifically are. So, you have all numbers are real numbers. So, remember that all numbers are real numbers, but they are broken up in different categories. So, we have our natural numbers. Our natural numbers are our counting numbers, which is like 1, 5, 50, 6, 100. Those are our counting numbers. So I'll put this 5, 8, 58, 2, whatever. Now, our whole numbers are all the natural numbers plus zero. So, zero is considered a whole number and not a natural number because when you learn to count, you're counting 1, 2, 3, 4, 5. You don't start with zero. So, natural numbers are counting numbers. So, whole numbers are zero, and then your natural numbers, which is you could say 28, 567, 32. Those are your whole numbers. All right, your integers are all of your whole numbers and their opposites, which are negative numbers. So our integers are going to include our negative numbers. So just negative numbers. And then our rational numbers are any number that can be expressed as a fraction. So remember, your whole numbers can be expressed as a fraction because they can be over one. So a whole number is a rational number, but also think about your fractions, and they can be negative fractions, as well as repeating or terminating decimals. And then our irrational numbers are going to be numbers with a non-terminating decimal. So, which means they always continue. And one number that we know that continues and never stops is pi. So, pi is our number one rational number, but it's also numbers that cannot be simplified under the radical, like square root of 2 or negative square root 5. Those are rational numbers. All right, so let's go to our definition. Part one, rational numbers, numbers that can be expressed as a ratio of two integers, includes perfect square, terminating decimals, and repeating. So examples, a perfect square is like 16 because that equals 4. A terminating decimal would be 3.125. It stops. A repeating decimal would be 1.666 repeating. And then a whole number, which can be 5. Those are your rational numbers. And then also as a fraction, 4 over 7. Irrational numbers are numbers that cannot be expressed as the ratio of two integers, including non-perfect squares, decimals that do not terminate or repeat, and pi. So, of course, let's start with pi because we know that keeps going. But you also have like 6.32598. And then when they put the three dots, that tells me that this number keeps going and it doesn't stop. So that's a non-terminating decimal. And also they said non-perfect square root. So like the square root of 6. I cannot break that down any further. It's just square root of 6. But here, square root of 16 breaks down to 4. So those are your examples. All right, create an equation. Using the numbers on your card, create equations, for example, and check. So we're not going to use the cards, but we're going to use our own example. So a rational number plus a rational number. So if I do, let's say if I do 3 plus 2/3. I can actually add that. And if I add that, that would be, if I change that to a 3, that would be 3/9. I mean, not 3/9, but 6/9. And then plus, change that to a 9. So that'll be 9/3 times 2. Oh, it's the same thing. No, it's not. Let's start over. I can change this to a 3. So I multiply by 1, no, by 3. 9/3 plus 2/3. And that's going to give me 11/3, which is an improper fraction, but it is rational. So this one checks out. Rational plus irrational is irrational. We did that. It's still going to give us a rational, so that is not possible. A rational plus an irrational is rational. So let's do 2/3 plus pi. If we add that in the calculator, it's going to give us another rational number. Hold on, I'm trying to add it myself. So 2/3 plus pi equals 3.14159, and it keeps repeating, so therefore that one checks out. A rational, no, that one doesn't check out because it's actually an irrational number. And then a rational plus irrational equals irrational. That one is correct because that's our irrational number there. A rational times a rational, so 3 times 5/6 is going to equal 15/6, which simplifies to, if I divide by 3, 5/2. So yes, that's rational. A rational times a rational gives an irrational. As we can see, no. A rational times an irrational is a rational. So let's do 4 times the square root of 2. That's just going to equal 4 square root 2. So that is not true. So that's not possible. And then a rational times a rational is irrational, which we see right here. So that checks out. So the conclusion from what we did is a rational plus a rational equals a rational. An rational plus an irrational number is going to give you an irrational number. A rational times a rational is going to give you a rational number. And a rational times an irrational is going to equal an irrational number. Circle always, sometimes, never for each statement. Only consider non-zero numbers. The square root of a rational number is always, sometimes, never rational. So the square root of a rational number, that's not, because that's going to be sometimes, because if I take 2 is rational, but if I take the square root of 2, it equals an irrational. 4 is rational, but if I take the square root of 4, it equals a rational number. So that's sometimes. And then the sum of the square root of 5 and a rational number is always, sometimes, never true. I think it is always, sometimes rational. And that's going to be never. Because if I do plus a rational number, let's do plus 3. It's just going to equal 3 plus the square root of 5, which is irrational. So it's always going to be, because even if I do square root of 5 plus 2/3, that's still going to equal 2/3 plus the square root of 5. So always having that square root of 5 is going to give me an irrational number. So that's always going to be, it's never going to equal an irrational number. All right, so thank you for your time. This was our lesson on rational and irrational numbers. I'll see you next time.